writing equations in point-slope form. So we've talked already about two other forms of equations. We've talked about standard form a little bit. We're going to come back to that. And we've talked about slope-intercept form. Slope-intercept form, our most friendly form of equation. Consider it my t-shirt and jeans. Standard form, very formal. Consider it my tuxedo of equations, forms of equations. We're going to talk about point-slope form, which is what I consider kind of your painter's clothes, or if you're going out to work in the yard, kind of your grubby clothes. It works, it gets you there, it's not the super friendliest looking, it tells you exactly what you need to know. You can use it to get to one of the other forms. That's generally when it's the most effective to try to use it. So let's take a look at point-slope form. So the linear equation y minus y1 equals m, and then x minus x1, is written in point-slope form. Very straightforward. There's a point and there's a slope. Where x1 and y1 is a given point on a non-vertical line, and m is the slope of the line. So we're pointing out that we're talking about a non-vertical line here. Remember, our vertical lines have an undefined slope. So I can't use any form of equations that has slope in it because a vertical line doesn't have a slope. So I can't write a vertical line equation in point-slope form. But if I have a point on the line, I'm going to refer to that point as x1 and y1. X and y, without the sub 1 there, x and y are the variables in my equation, as we always have an x and a y in our equation, and my m is my slope. So if I have a point on that line, I can figure out 1 point. If I know 2 points, I've got a slope there. Or maybe I've probably been given the slope. So let's look at a situation where we would use point-slope form. Write an equation in point-slope form for the line that passes through -2, 0, with a slope of -3/2, and then we're going to graph the line of that equation. So we're going to take our point-slope form, y minus y1 equals m, and then parentheses x minus x1, and we're going to substitute in. This is really a very plug-and-play equation. We just cram that information right into the equation. So I'm going to take my y1, which was 0, plug that in for y1, y minus y1 equals, here comes my slope, second set of parentheses, x minus, and then I plug my -2 in there. I do a little bit of simplifying with this equation. I still want it to look like this general form here. So I simplify this to y, because y minus 0 is just plain old y, equals -3/2. I'm going to leave that as a slope. I'm not going to do my distributive property here. And then in parentheses, x, I'm going to simplify this, subtracting a negative into a 2, +2. So I have x minus 2. I should be able to look at an equation in point-slope form and pull out the slope and pull out the ordered pair. So when I look at this equation, I see that the slope is -3/2. It's just sitting right there. And then I realize that I subtracted my x value. So if that's positive, I know I subtracted a negative. So my x value should be -2. And I know I subtracted my y value. So if there's nothing there, I know I must have subtracted 0. So I should be able to pull that information out of this form of equation also. It's plug and play again. So those pieces of information are sitting right there in the equation. The last part of this was to graph the equation, which is pretty straightforward if I'm given a point and a slope. Again, when we graph, I need a starting point, and then I need to know where to go. So here's my starting point. I'm going to -2, 0 on my coordinate plane over here on the x-axis. And then I'm going to use my slope with rise and run, a rise of -3 going down 3, and a run of +2. I'm going to do it a second time just to really make sure what my line looks like. A rise of -3 and a run of 2. I have a few points on there. I want to graph all the points from this equation. So I'm going to draw myself a nice long line. And there's point-slope form.